Have you ever looked at a giant skyscraper or a super complex hospital and just wondered, how on earth do they build that without it all turning into total chaos? Well, the secret isn't just about the steel and concrete. It's actually about managing this huge invisible traffic jam of digital information. And really, understanding this hidden digital world is the key to everything.
And it all really boils down to this one big question. See, in today's world, every single project gets built twice. First, it's built as a super detailed digital model, and then it gets built in the real world. So a tiny, seemingly insignificant mistake in that digital version, while that can bring the physical construction to a grinding halt.
And this is a perfect example of what we call the construction shockwave. So let's say the plumbing team resubmits their model. Just a simple update, right? Nope. That one little change now clashes with the digital wall frames, so that holds up the fire sprinkler team, who now can't check their own work. And because of that, the final sign-off for that entire area gets missed, which can delay real-world work for weeks. It is a total chain reaction.
Okay, so if we want to stop these shockwaves, we first have to get what's causing them. These disruptions are called variation, but here's the thing. They aren't all the same. They actually come in two totally different flavors, and knowing the difference is, honestly, the first step to taming all this chaos.
So let's break these two types of variation down. On one side, you've got common cause variation. Think of this like chronic sloppy driving. You know, teams using weird file names or not following the same modeling standards. It's that constant, low-level friction that just slows everything down. Then, on the other side, you have special cause variation. This is more like a sudden, unexpected car crash, a last-minute design change from the architect, or a supplier sending the wrong data for a piece of equipment. One is a process problem you can fix internally, the other is an external shock you have to react to.
So, how do we actually measure the health of this digital highway? Well, we start with something called throughput. Now, this isn't about how fast individual cars are moving, but how many cars are successfully getting to their final destination, all coordinated and signed off. A high throughput means your traffic is flowing just right and work is actually getting done.
Now, if throughput is about how many cars get there, cycle time is all about how fast each individual car makes that journey. It's the total time from the second a digital model is released to the moment it gets that final stamp of approval. You want to see lots of cars arriving? That's high throughput. In the shortest time possible, that's low cycle time. That's the dream.
And this all brings us to this really core idea, the parade of models. You know, on a real construction site, you have what's called a parade of trades. The concrete crew has to finish their work before the framers can start, and the framers have to finish before the electricians show up. It's a sequence. Well, that exact same parade, that same sequence, has to happen in the digital world first.
And when that digital sequence breaks down, you get a collision. Just imagine the mechanical and the electrical teams are modeling the exact same space at the same time, but they aren't talking to each other. Their digital ductwork and their electrical conduits are going to literally run right through each other. And that just means tons of rework, wasted time, and yeah, probably a lot of finger-pointing.
Or, and this is maybe even worse, you get this. The electrical team is all set to go, they're ready to work, but the mechanical model they need to coordinate around hasn't even been uploaded yet. So what happens? They're completely blocked. Work just stops. And that's not just a delay for one team, it's a full-on traffic jam that backs up absolutely everyone behind them in the parade.
But when it works, oh, it's beautiful. It looks like this. The mechanical team finishes their area, they run their quality checks, and they give a clean, perfect handoff. The electrical team immediately picks it up and starts their work. No clashes, no waiting. This smooth, uninterrupted progress, that's what we call flow, and it's the ultimate goal of the entire system. Okay, so we know some disruption is pretty much inevitable, right? So how do we protect the project from just grinding to a halt every time something goes wrong? Well, you can't eliminate all the variation, but you can plan for it. The answer is to build a buffer zone, and we do that using a pretty powerful set of ideas from the Lean Manufacturing Toolkit.
And there are really three main types of buffers we can use. First up is a schedule buffer. This is just like leaving for the airport an hour early. You build in these little time cushions by setting internal deadlines way ahead of the final due date. Then there's an inventory buffer. Think of this like having an alternate route planned for your commute. If your main work area is blocked, the team can just pivot to a secondary area that's already prepped and ready to go. And finally, a capacity buffer is kind of like adding an emergency shoulder lane on the highway. You strategically add extra time for the most complex, trickiest parts of the project, where you know delays are pretty likely.
But here's the really important part about all this. Buffers are not supposed to be a permanent crutch. The philosophy here is called lowering the river. So imagine your workflow is a river, and the buffers are extra water that helps your boat glide right over any hidden rocks. Now, you could just leave the water level high forever, but the real goal is to slowly lower that water level, reduce the buffers, to expose those rocks. Those rocks are the weak links in your process. You expose them, and then you can fix them for good.
So managing the system is one piece of the puzzle, but what about managing the people? Well, that all comes down to making the workflow reliable. And you do that with clear promises, solid plans, and a really simple way to measure the whole thing.
To measure how reliable teams are, we use this brilliantly simple metric, percent plan complete, or PPC. At the beginning of the week, each team makes a set of promises about what they're going to deliver. PPC is just a way of asking, what percentage of those promises did you actually keep? And it's not about playing the blame game. It's about building a culture where people can make and keep dependable commitments.
And here's what that looks like in the real world. This team made 6 commitments at the start of the week. By the end, they had met 5 of them. That gives them an 83% PPC. So now the whole team can have a really productive, totally blameless conversation about why that one commitment was missed. Was the task bigger than they thought? Did they need info from another team? This simple number drives real, honest improvements week after week.
And the person who gets to pull all these levers, managing variation, creating buffers, tracking reliability, that's the virtual design and construction manager. They're the flow master. Think of them as the air traffic controller for this entire digital project.
You know, their most powerful tool isn't some fancy software. It's asking the right questions. A bad manager asks, "Why isn't this done yet?" But a flow master, they ask, "What's blocking you, and what can we do to help you get this done?" Their job isn't to crack a whip. It's to serve the team by removing roadblocks.
At the end of the day, their entire job really boils down to 4 key goals. First, protect the flow of work. Second, help teams make commitments they can actually keep. Third, actively manage the handoffs between all those different teams. And finally, make everything visible. Use data to spot bottlenecks before they turn into a full-blown crisis.
So here's the real takeaway from all of this. These ideas aren't just for building skyscrapers. I mean, think about your own work. Whether you're launching a website or writing a report or even planning an event, you have a parade of models. You have dependencies. So where are your potential traffic jams? Thinking about flow and buffers and clean handoffs, that can prevent gridlock in just about any complex project you can imagine.